Hi everyone, welcome back to our YouTube channel Becoming a ROS Developer. I'm Desire and today we've got Sajjad who has just completed the course C++ Basics for Robotics, and you'll be giving us a presentation on that. So without further ado, let me hand over the platform to him so he can begin his presentation. Alright, whenever you're ready, Sajjad.
Hello everyone, I hope you are doing great. My name is Sajjad. I'm presenting you C++ Basics for Robotics. I'm starting the classed version, which we use the class C++ to run the robot and see how it's goes. So go deeper in the code when the robot is finished turning.
Okay.
It's now like 4 and 4, and it will be like in 0.6 with so okay, yeah, so it stopped. Now should I go to the class script, or I just should run the no class version too?
Run the no class version as well so we can see that when it working.
Okay, no problem. No class version is like just showing that all the function that is asked working, so it's not checking the object avoidance. So I just put it in the right direction to avoid hitting other stuff. It will go back and forth and turning left and right to show everything is working. So I update my terminal with this code, which is like no class version, and you can see that all the function is asked will be appeared. Like this is the maximum angle, minimum angle, minimum maximum, and this is the scan range that LiDAR scan returns. There is no infinity at the moment. Oh yeah, there is someone here, which we handled in other functions. This is the current position, current orientation, and the distance from the origin. The question was asked to just calculate the distance between 2 points, and I take the origin for the 1 point. Robot now is moving forward, if you saw that, and moving backward. This is the simple moving forward with the steep time function, and the next move is like going forward with a specific time. So went forward with 4 seconds, and it will return to the first position with the same amount of time and same velocity. And you can see that like the minimum array at the moment, maximum array at the moment, and its index and the velocity that the robot went. Like I guess I put it in the wrong way because it shows 0. It should be like minus 0.1, and this is angular velocity of IMU, and this is linear acceleration, which we have like a gravity in the z direction.
Okay.
And now robot is turning left and right.
Okay.
With this is the simple turning. After that is turning with time, and after that it will be turning left and right with the angle, with a specified angle.
Yeah. Okay.
Okay, and yep. So this is like there is 2 more step function, 2 step turning function, which is this is the turning left for 90 degrees, and it will be turned back to the right with same amount.
All right. So let's get to see the code itself, right? So you first show us the class version, and then we'll go to the non-class version.
Okay, you can see that the program stopped without any problem.
Yeah.
So we go to the classes. This is the way we define a class in C++. We use the word class robot control, the name that it was written in the pre-written code.
Mm-hmm.
I just modify some part of it to do that.
Mm-hmm.
So this is the function that I use for the current position. I make a dictionary. I guess they call it mapping C++, but
Yes.
I'm very familiar with Python. So
Yeah. Okay.
uh, I return a current position. We could just print it, but I make a dictionary to have the value when I want to calculate the distance between the the point right here and the previous point to calculate the travel distance so far.
Mm-hmm. Okay.
Also, I do the same thing for orientation. We have also the laser information. This just for printing, but I also make a map here too. And this is the part that we have the main function of the our robot control.
Mm-hmm.
This is the uh, construction of our class constructor. This is just appear once, and it's like a statics of the robot.
Mm-hmm.
And this is the class destructor. I didn't write anything because I'm not very familiar with this part.
All right.
And this is robot motion. You assign a linear velocity and angular velocity. I
Yes.
use this function to do the doing a time movement or a distance movement. I just pass the amount to the this function. I use it. So this is a this is the function that I used for showing the velocity, linear velocity and angular velocity.
Mm-hmm.
This is the This is the function I talk about it that can calculate the distance between this point and the previous. You can see that I passed the point coordination and it calculates the distance between just 2 points. But
Yep.
I saved the previous point and added to the last amount of travel distance to have the total distance. This is the forward and going forward section. We have a timed version, which is the same thing just with the sleep integer as the sleep time.
Yes.
And this is the for going forward with the distance. We calculate the time that we need to do to travel this distance, and I pass the calculated time. I make it first integer and then pass it to the my function for sleeping.
Mm-hmm.
This is the same scenario for going backward and turning left or turning right. For the obstacle prediction function, we calculate gather the front 90 degrees of the robot, a list of displays. I use the vector type of variable,
Mm-hmm.
and mm, I use if there is nothing in it, it means that if everything is bigger than 0.31, it
Mm-hmm.
means no obstacle is ahead.
Yep.
But if like more than half of this vector is more less than 0.3, it means it's a big obstacle, so it probably is a wall. If it is less than half of the vector, it means it should be an obstacle probably. So that's how it's works. And for the direction, it's very easy things to do. We just divide the whole circle to the 16 particles, and based on the um, divider, we can decide that this is the northwest or north or whatever.
Mm.
And for the naive obstacle avoidance, I just follow the instruction in the course material. It's when it's nothing is when it's nothing ahead, it go forward, and when there is when there is a object ahead, a sense object ahead, it check the right side and left side to decide turn in which direction.
Mm-hmm. All right. So, I want you to do me one favor, Sajjad. So,
Okay.
you have given like very detailed explanation of what you did. So, I want you to run the class division right one more time. That's the one you ran it the first time, right?
Okay.
Yes. So, I want you to run it on the real robot again so that we see it executing and. Just for good
Yeah,
measure,
sure.
because I thought that was quite nice. It showed that it was avoiding obstacles very nicely. So
Okay. This is again, we should wait 10 seconds. I put this sleep time for reading this stuff. But yeah, it start moving. You see there is no obstacle, and
yes,
it's going to the south,
yes.
and it will be shown the linear velocity, which was 0.1, and it wasn't any angular velocity. And it's try to not hit anything. And you see when it was near to the wall, it uh, predicted very well, actually. It understand there's a wall because the more than half of that list was like less than 0.3.
Yeah, I also noticed that it stopped there.
Yeah.
Okay, I see.
I put like a 0.5 second stop in each iteration to don't freeze the terminal, so you see a lag between updating stuff. That's why for the
Okay, so that you could be able to at least keep track of what's happening. But right now, I
yeah
see it seems to be like stuck in a rotating loop. But this didn't happen
yeah
initially, so try terminating it and then maybe move it out of
okay,
this so we can try again.
sure.
Okay, I think that position is okay. So let's get it going again.
Okay. I guess there's a problem. I don't know if this is because of my network or there's a problem with the robot connection, but uh, it returns segmentation fault.
Looks like there might be some memory leak,
Ah,
but let's see. Okay, all right. I think we'll
do
get
you
it.
have
Yeah, okay, so that's something with C++ code. So there is some sort of bug, but anyway, it's okay. We saw it working, so we have a look at it later on. Okay, so let's get into the questions without dwelling much on this. So I would like
okay?
to know, you used two major container types, right? So there was the vector, and then there is the map, right, which you call a dictionary. I understand it's the same thing, right? It uses key values. It's a key value per container, right? But what I want you to explain to me is, can you give some detail on how you get access to the values in the different containers, right? So when you want to access something in a map, how do you do it? And then when you want to access something in a vector, how do you do it?
Okay, for the map, I have an example here, right here.
Mm-hmm.
It's very easy. You define in Python we call it key. I'm not familiar with the
It's still a key,
mm,
but yes.
oh, okay. Okay, great. So when you name the map, like at this point, I call it CUR underline ORI
Mm-hmm.
and pass the key as a string because I define it as a string.
Mm-hmm.
My key are a string. It could be integer or whatever.
Yes.
And my value is a float number, which I read it from the robot interface.
Mm-hmm.
It could be any type of the variable. When I pass the key, it returns me the value.
Mm-hmm.
But at this example, I assign this value to this key actually.
Mm-hmm.
And your question was about vector also. So let me find an example. Okay. So for vector, we have a we can say that we have a pre-assigned key, which are the number which start from 0,
Yeah, the
and
index.
it called index
Mm-hmm.
exactly. And I read the index from this amount to this amount because these are the index of um, uh, 90 degrees front of the robot.
Mm-hmm.
But by passing this amount to the vector type of variable, we can have its value.
All right. Wonderful. Thank you so much. Thank you so much, Sajjad. So let me just
Mm.
check if I have any other questions. So the other thing that I noticed you did in your code is you did a casting, right? You were casting some values. So I think it's somewhere up there. I don't remember what you were casting to what. Yes, there you go. Can you explain what's going on there? You did a static cast, right? Can you explain which type is being converted to what type?
You talking about displays?
Line
Like
226. Yeah, so line 226, that one.
yeah,
Yes. Mm-hmm.
yeah. Because my sleep time work with an integer,
Mm-hmm.
so I use this method to run the number to the integer. Like when it's like 3 point something, I obliterate the value to the integer to use it in my function, because my function only works with the integer number, and in the C++ we cannot pass the number if the type of the value doesn't match with the input value of the function.
Yes. Okay. All right. Understood. So, just a follow-up question. So, what would happen if you try to cast like something that is, let's say, a string to an integer, for example, right? What is it that is unique about the float type, which is the one that you're actually casting, and the int type? What is it that makes that process plausible to that makes the
because
two to
it's
be
a
cast into each other?
because it's a number, so we can turn it to the integer. Like I'm not sure, but
Yeah,
in
yeah, you're on
Python,
the right path. Yes, it's exactly that. So basically, what happens to the decimals is that they'll be truncated
yeah.
when you do the cast, right? So there is some data that's ignored. So I,
Okay.
I, I think that's okay. I'm glad you showed that you understand what's going on there. That's the most important bit I wanted to get from you. So, well done on that bit. Um,
Mm.
all
Thank you.
right. So thank you very much, Sajjad, for a wonderful presentation. And
Thank you so much.
just hang on here and
Okay. I have no feedback from you because of, I don't know, there's a I cannot see you or anything. Update me totally.
just hang on. Okay, let's finish this first. Okay. All right, everyone. So this was just presentation. I would like to congratulate him for a job well done, and also for getting the courage to come and showcase his work. And would like to encourage all those of you who would want to do the same thing to finish your projects, make a booking, and then you can also come and present by demonstrating your work on a real robot. So until next time, keep pushing your ROS learning. Bye bye.